Hello, and welcome to the presentation of my final paper for IST 602, Information and Knowledge Organization. My name is Julie Rozier, and for my literature review, I decided to explore how linked data is being used in library and archival contexts, especially related to description and discovery. My goals for this paper include, first, gaining a better understanding of what linked data is and how it functions. Then I wanted to look at the current research to learn about efforts being made to build infrastructure for linked data, convert metadata according to linked data standards, and use linked data to augment the discoverability of library and archival collections. Finally, I wanted to report back on lessons learned from these experimental projects and linked data-focused working groups. Linked data builds upon technologies developed by Tim Berners-Lee, the inventor of the World Wide Web. Instead of linking together HTML documents that can only be read by humans, which has become the primary function of the web currently, linked data refers to data that is published in a machine-readable format so that it can be manipulated automatically. Berners-Lee sought to augment web pages with data targeted at computers and thus transformed the web into what he called the semantic web, or Web 3.0. In order to do this, each discrete piece of information, such as names, subject headings, geographic areas, and types of relationships, is assigned a uniform resource identifier, or URI. Data then can be published on the web using RDF, or Resource Description Framework, which forms URIs into statements called triples to link those pieces of information together. A triple is made up of a subject, predicate, and object, each of which can be assigned a URI. For example, the statement Mary Smith is employed by XYZ Corp. Can be expressed by replacing the subject, Mary Smith, the predicate is employed by, and the object, XYZ Corp., each with their own URI. Then, users may follow any of those URIs, which can function similarly to uniform resource locators, or URLs, which we're more familiar with, and find what other pieces of information are also linked to that same URI. When those triples are linked together to other entities, they start to form a knowledge graph. As you can see there on the right, we see a graph depicting some of the connections within the Flintstones universe. Although the concept of the semantic web has been around since 2001, it has certainly not been universally adopted at this point. So it is necessary for people to add URIs to the data that they are connected to and continue to build and publish RDF triples and add to that global knowledge graph. In my research, Wikidata showed up repeatedly as a knowledge hub where novice users could participate in creating and editing linked data. Anyone with internet access and a free user account can participate, similar to its sister project, Wikipedia. Besides getting hands-on practice with using URIs and RDF, another benefit of Wikidata is that it can encourage community involvement with library and archival collections, as users familiar with those collections can add their knowledge to the Wikidata hub and make data contained in a local collection available worldwide. Libraries and archives are very familiar with creating and publishing data about their collections. Currently, library and archival metadata structured to be published on the web is often written in extensible markup language, or XML. The projects I studied that were focused on reshaping descriptive metadata to be more discoverable on the semantic web then had the task of breaking apart elements of the XML documents to find the URIs for small bits of data and creating RDF triples that described how those data within the library and archival collections are connected, and making them available to be further linked to other data published on the web. Other exciting projects focused on enhancing discoverability of resources by employing linked data technology. Michigan State University libraries used linked open data to pull additional context into a knowledge card when users searched the catalog. So, if someone searched the subject social movements on their catalog, they would get a little knowledge card panel that would pop up to add additional context. It would provide a brief description extracted from Wikipedia of social movements, and it would also provide a broader term like social history and a narrower term like Black Lives Matter movement. This could help the user continue searching with more knowledge at their fingertips. Another use case out of Indiana University linked Homosaurus, a community-created LGBTQ subject heading vocabulary, which uses linked data, with LCSH terms, or Library of Congress subject headings. This helped mitigate bias towards a historically marginalized community in their metadata, and also helped to augment and update the search experience. In the end, I learned a lot from reviewing the literature and writing this paper. I had 3 takeaways that I wanted to share. First, linked data helps to reduce the siloing of information between various fields and/or institutions. Also, information professionals can be key contributors to the linked data movement and all the benefits that it has to offer. And finally, I found in the literature that library and archives staff familiar with the benefits of linked data still felt the need to advocate and educate others so that in their institution, especially higher up, to ensure full buy-in on future linked data projects. Thanks so much for watching. Here are the citations for the studies that I referenced. I hope this talk made you as curious and excited as I am about linked data. I think that the semantic web holds great potential for libraries and archives. Please let me know if you had any questions and feel free to leave a comment below. Thanks so much.